Good afternoon, everybody. How are you all?
Good afternoon, sir.
कैसे हो सब लोग? Shall we start? So,
Yes, sir.
in yesterday's class, what we have done, first of all, we found the range of these four functions, five functions. Anybody having any doubt with these functions? Anyone? Tell me. All right. Then we have done the greatest integer function. Then its graph, its domain is x belongs to R, its range is y belongs to z. Then we have done greatest 1 upon greatest integer x function, its domain R minus 0 to 1, because between 0 to 1 denominator gets 0. Its range is reciprocal of all non-negative integers, non-zero integers. Then we have done fraction part function, that is x minus greatest integer function. All right. Then logarithmic function I taught you, which is always increasing or always decreasing, depending upon the base of the log. If base of the log is more than 1, it is always increasing. And if base of the log is less than 1, it is always decreasing. All right. Then we have done exponential function. That is a to the power x. If a is more than 1, it is increasing. If a is less than 1, 0 to 1 means it is decreasing. And then finally, I have done signum function. Anybody facing any difficulty in any of these concepts, do let me know, please. Anyone? Yes, anybody? Fine. Mahesh, is it okay?
Yes, sir.
Now we will do, this is the very important portion with respect to 12th class, that is classification of function. Classification of function. Now, classification is done. A function can be 1, 1, oblique, many, 1. A function can be 1, 1, oblique, many, 1. Then a function can be onto, oblique, into. These are two definitions for 1, 1, many, 1, onto, and into. Am I clear? Now, for 1, 1, many, 1. Now see, a function has to be one of 1, 1 or many, 1. Got it? A function has to be either 1, 1, oblique, many. But neither none nor both. Got it? So if there is any function you see, either it will be 1, 1 or it will be many, 1. But it cannot be both. Like you remember we studied symmetric and skew symmetric matrices? Do you remember that? Lakshmi?
Yes, sir.
You remember we have done symmetric and skew symmetric matrices?
Yes, sir.
But there are matrices which are neither symmetric nor skew symmetric. Also, there are matrices which can be symmetric as well as skew symmetric both. Which functions are those? There are functions which are symmetric as well as skew symmetric. You remember which functions are those? like null matrix. It's a symmetric as well as skew-symmetric matrix. But in case of 1, 1, many 1, neither a function can be both, nor a function can be like neither 1, 1 nor on many 1. Every function has to be either 1, 1 or many 1. That's it. Similarly, every function has to be either onto or into, but neither none nor both. But it cannot be both onto into simultaneously. It cannot be none of onto or into. So it has to be one of them. Now theory for onto, okay, there are few words which I want to clarify also. Onto is also called surjective. Surjective. And 1, 1 is also called injective. Injective. Surjective and injective. And if a function is both 1, 1 onto, if a function is both 1, 1 and onto, we call it bijective. There is no particular name for into. There is no different particular name for many 1. For 1, 1, it is injective. For onto, it is surjective. And for 1, 1 onto combine, it is bijective. Now see, theory behind 1, 1 onto is very much clear. If codomain is equals to its range. Let me remind you again what is codomain. If they say function is defined from A to B, then this entire set B is what we call codomain. This entire set B is what we call codomain. So if codomain is equal to its range, function is onto. And if codomain is not equal to range, function is into. If codomain is equals to its range, function is onto. And if codomain is not equal to its range, function is into. Am I correct? So there is no further discussion about it. From the last couple of lectures, we have been doing how to find the range of a function. And so if we can get the range, if it is equal to codomain, it is onto. We got the range. If it is not equal to codomain, then it is into. Now, there is a lot to talk about 1, 1 and many 1. See, I'm making two mappings. This is A, this is B. It is A, B, C, D. It is 1, 2, 3, 4, 5, 6. A going to 1, B going to 2, C going to 4, D going to 5. Now there is another mapping. A to B function is defined. A, B, C, D. 1, 2, 3, 4, 5, 6. A going to 1, B also going to 1, C going to 3, and D going to 4. What substantial difference do you notice in these two mappings? Tell me quickly. Tell me, is there any substantial difference that you notice in these two mappings? Quickly tell me. Karthik? Tejaswini, do you notice some difference in these two mappings?
Yes, sir.
What is that? There is no element in the codomain set is image of more than more than one element. Means every element in the codomain set, either it is not the image of any element, or if it is the image of any element, it is the image of only one element. Yes or no? Here, if you notice, at least one element in the codomain set is image of two or more elements. Understood? Like in the domain set, there is no shared image. Everyone is having one image that is not shared with any other element of the domain set. In many-one function, at least two elements are there in the domain set which are having same image. You can also write at least two elements in the domain set have same image. Am I correct? Is it okay with everyone? At least two elements in the domain set have same image. So this is the basic understanding behind one and many-one. So just a moment. This is one mapping. And this is many-one mapping. Am I clear? Now, how to check if a function is, how to check if a function is one oblique many-one. Now, there are 3 or 4 methods. Fine. So, first of all, I mention those methods which are there in your school syllabus. Method 1. Method 1 ko we will do step by step. Let x1 comma x2 belongs to domain of the function. Domain of the function. And let fx1 is equals to fx2. So it is like in the domain, there are two elements x1 and x2 which are having same images. That means you assume function is what? Tell me.
Many-one.
Many-one. You started assuming that function is many-one. Now so this is your first step, second step. Now make the equation in x1 and x2, and then simplify the equation. Next, now this is the concluding step. If x1 equals to x2 is the only solution you are receiving, then function is 1, 1. Got it? And if x1 equals to x2 is not the only solution, means you are receiving more solutions also, like x1 equals to 1 by x2, or x1 equals to minus x2, or x1 plus x2 equals to 3, or something like this. So if x1 equals to x2 is not the only solution, then function will be many. Am I correct? Tell me. So if x1 equals to x2 is the only solution you are receiving, this function will be 1, 1. If x1 equals to x2 is not the only solution you are receiving, then function will be many, 1. Am I correct or wrong? So this was your method 1. Now before proceeding, we'll do an example on it. Just a moment. Got it? Now, like for example, a function f defined from R to R, fx equals to x cube, x to the power 4. Fine. Check for 1, 1, many 1, on to, oblique into. See the solution. First of all, I'll check for 1, 1, oblique many. Let x1, x2 belongs to domain of the function and their images are same. Fx1 equals to fx2. Now, what is fx1? Fx1 will be x1 to the power 4. What is fx2? x2 to the power 4. This is x1 to the power 4 minus x to the power 4 equal to 0. Yes or no? That is x1 square minus x2 square into x1 square plus x2 square equal to 0. This can further be written as x1 minus x2 into x1 plus x2 into x1 square plus x2 square equal to 0. Now see, this cannot be 0, I know. The only solution is x1 equals to x2 equal to 0, which we are already getting x1 equal to x2. So either x1 equals to x2 or x1 plus x2 equals to 0. Now tell me one thing. Is x1 equals to x2 only solution you are receiving? Tell me. Is x1 equals to x2 the only solution that you are receiving? Hello?
No, sir.
You are receiving more solutions also, like x1 equals to minus x2. So, since x1 equals to x2 is not the only solution, function is many. Understood? Then If I check for range of fx, okay, tell me what will be the minimum value of x to the power 4? What will be the minimum value of x to the power 4? Is it 0? Because it's a perfect perfect square of x square. So it can never be negative. Yes or no? So x to the power 4 minimum value is 0. So range will be what? Range will be 0 to infinite. Whereas codomain given to you is what? R. This is your codomain. Is codomain equal to range? Codomain is not equal to range. So function is int. Am I correct? Have I made my point clear?
Yes, sir.
So this is one way of checking if a function is one or many one and onto or into. Now, method 2. Method 2. Shall we? Now, if by checking randomly, you can see that there are more values of x for which we are getting same image. We can say function will be many one. Got it? Like you see the function, now you check randomly for 3-4 values. And if you see that images are repeating, means say 2 pay and at -2 we are getting the same image, then we will say this function is many one. Like for example, a simple function is f from n to n fx equals to n by 2 if n is odd, if n is even, and it is n plus 1 by 2 if n is odd. N by 2 if n is even. And n plus 1 by 2 if n is odd. Same question. Check for 1, many one, onto or into. Now see, let us start judging the values now. This is function fn. Tell me what will be f1? Tell me. What will be F1? 1 is odd. So we will put it in the lower branch. What is the image going to be? 1 plus 1 by 2. That is 1. What will be F2? F2 is even number. So we will put it in the upper branch. So F2 will be what? 2 by 2. That is 1. So now you realize that 1 and 2 are having the same images 1. Similarly, if you check for F3, F3 will be what? 3 plus 1 by 2, that is 2. And F4 is 4 by 2, that is also 2. So these things clearly suggest that this function is going to be many one. Am I correct or wrong? Tell me. Now, if you realize for all the even numbers, you are getting F2 is 1, F4 is 2, F6 is 3, F8 is 4, and so on and so forth. So you are getting image as all the natural numbers, which is also the codomain. So range is what? Range is y belongs to natural numbers, and that is equals to codomain. So that means function is what? Onto.
Onto function.
So this is many one onto. Am I correct? Is it okay? Now, let's go with method 3. Draw the graph of the function. Draw the graph of the function. Fine. Say you have drawn the graph. There is a possibility that the graph you have drawn is something like this. And there is a possibility that the graph you have drawn is something like this. What is the difference in these two graphs? This graph is always increasing. This is not always increasing. Now, if in the graph of a function, let us say there is a line which is parallel to x-axis, and that line is increasing the function at more than 1 point. That means, say this is your x1, this is your x2, and this is your x3. That means this x1, x2, x3, at these 3 points, we are having same images. Yes or no? Tell me. So, if any line parallel to x-axis intersects the graph of the function at more than 1 point, if any line parallel to x-axis intersects the graph of the function at more than one point, function will be many-one. And if any line parallel to x-axis intersects the graph at max one point, function will be 1. Yes or no? So if in the graph of a function, any line drawn parallel to x-axis is intersecting it at more than one point, function will be many-one. And if any line parallel to x-axis intersect the graph at max one point or it do not intersect, then the function will be 1, 1. Now these functions are always increasing or always decreasing. These functions in the left side, these functions attains a maxima or minima and are not always increasing or always decreasing. Got it? So not always increasing or always decreasing means they are having a maxima or minima in their interval wherever function is getting turned. So the moment it is turning, it will become many-one. Understood? Am I clear? Now, let's do some examples. One example on it also. Like there's an example. Fx equals to mod x minus 2 plus mod x minus 2. And f is defined from R to R. If you remember in the last class, we have done its graph also. So how did I tell you to draw the graph? Draw x-axis. Mark the points where mod is changing behavior 2 and 4. Now, f of 2 is what? F of 2 will be 2. F of 4 is what? F of 4 is also 2. So at 2 and 4, image is 2 only. If I see this much of graph only, it is already many-one. Yes or no? So still, if I check for f of 5, 5 at 5, it will be 5 minus 2, 3 plus 1, 4. So at 5, it will be 4 like this. I'll check at 1 also. F of 1 will also be 4. So it is 1 comma 4. It is like this. Now if you realize there will be a line parallel to x-axis which is intersecting it at more than one point. Yes or no? So function is many-one. If I check for range, range is y belongs to 2 to infinite. Do you see this point is 4 comma 2? This point is 2 comma 2. So range is 2 to infinite. So whenever range is 2 to infinite, which is not equal to codomain. So function is into. Tell me if it is clear to you or not. Yes. Shravya, understood better? Renuka, Renuka saying once again, that is nothing. I just have drawn the graph. And these graphs I have taught you in this class. See, this is the graph of this function, or another one. This is the graph of this function x minus 2 mod plus twice of mod x minus 3 plus x. So there I have taught you how to draw these graphs. Got it? So graphs are there. Now the function is many one because a line parallel to x-axis is intersecting it at more than one point. All right. Okay, let's do another example. F from R to Z, fx equals to greatest integer x. This is greatest integer function. Okay, tell me, is it one or many one or onto or into? Quickly. Tell me quickly. If you realize f of 2.2 is what? That is greatest integer of 2.2. That will be 2, yes or no? And f of 2.8 is what? That is greatest integer of 2.8. That is also 2. So there are so many infinite number of elements between 2 and 3 itself having image as 2. Then there are infinite number of elements between 3 and 4 having image as 3. So that means with this you can conclude it is many one function. Now range of greatest integer function is what? Y belongs to all integers. And that is also the codomain given to you. That is also the codomain. So function is what? Onto. Am I correct? So it is many one on two. All right. Okay, but let's do one more example. F from R minus 1 to R minus 2. F from R minus 1 to R minus 2, fx equals to 2x minus 3 upon x minus 1. Check for 1, many one, onto and into. Yes, give it a try quickly. Give it a try quickly. Now see, let x1, x2 belongs to domain of the function and let fx1 equals to fx2. So it is 2x1 minus 3 upon x1 minus 1. It is 2x2 minus 3 upon x2 minus 1. Got it? Now cross multiply. So it will be 2x1 x2 minus 2x1 minus 3x2 plus 3 is equals to 2x1 x2 minus 2x2 minus 3x1 plus 3. This 2x1 x2 cancel, this 3 cancel. Understood? Take this 3x1 to the left side, you will get x1 equals to x2. Now, since x1 equals to x2 is the only solution, function is 1, 1. Understood? Now, for onto into, let y equals to 2x minus 3 upon x minus 1. Cross multiply xy minus y is 2x minus 3. So x times y minus 2 is y minus 3. So x comes out to be what? Y minus 3 upon y minus 2. Understood? So y can be anything except 2. So range belongs to r minus 2. That is equal to, what is the codomain given to you? Codomain is also r minus 2. Do you see that? So that is equals to codomain. That means function is onto. So this function is 1, 1 onto. And what do we also call it? Bijective function. Am I correct? So this is a bijective function. Got it? So now what all we have done today, let me recall it once. We started with classification of function. In the classification, we know a function can be 1, 1, many 1, or it can be onto into. It has to be one of 1, 1 or many 1. Neither it can be both, nor it can be neither. So it has to be one of 1, 1 or many 1. Similarly, onto or into. So a function has to be onto or into. Neither both nor none. Onto is completely sorted. If codomain is equals to range, it is onto. If codomain is not equal to range, then it is into. Understood? In the 1, 1, each element in the domain set should have an image that is not the image of any other element. Means no two or more elements should have the same image. Whereas In many-one mapping, there should be at least two elements in the domain set. At least two elements in the domain set should have same image. Got it? Now, how to check if function is a 1-1 or many-one mapping? I told you three methods. I'm just quickly recalling. Let us assume x1, x2 belongs to domain of the function and they have the same image, means fx1 equals to fx2. Now get fx1, get fx2, equate them and solve for x1, x2. Now, if x1 equals to x2 is the only solution you are receiving, function is 1-1. If x1 equals to x2 is not the only solution, function will be many-one. Means you are receiving more solutions also. Now, a simple example I have done, fx equals to x to the power 4. So first of all, I assumed x1, x2 belongs to domain of the function, fx1 equals to fx2. After simplification, I realize there are two solutions, x1 equals to x2 or x1 equals to minus x2. That means since x1 equals to x2 is not the only solution, function is many-one. Range is simply x to the power 4 function. Range is 0 to infinite. That is, codomain given to me is R, so function is into. Then the second strategy to check for 1-1 many-one is you just put some values. Got it? And if we are receiving same output for any two or more inputs, you can say it very confidently that the function is what? Many-one. See, using this method, commenting for a function to be 1-1 is quite critical. Why? Say you have tried for 5 values. All the 5 values you are receiving different outputs. Getting my point? You place 5 values in the function and at all the 5 values, you are receiving different outputs. That means what? Since the function is defined for infinite number of values and you cannot check for all of them, you directly cannot say it is 1-1. But yes, if I got same image for any two elements, which is very simple, then we can directly say it is many-one. Then an example. Then with the graph, I told you, if a function is always increasing or always decreasing, it will be 1-1. If a function is having hump in its graph, like it is increasing then decreasing or decreasing then increasing, means it is having some maximum or minimum value. That function will be many-one. Got it? One graphical question we have done then. Greatest integer function, certainly many-one onto. And another function, rational algebraic linear by linear type. Anybody having any doubt? Lakshmi, understood everything, beta?
Yes, sir.
Tejaswini, got it?
Yes, sir.
All right, that would be all. Okay, now with this conclusion, you can end your NCRT exercise. NCRT, in the function chapter, this is the second exercise. And I don't remember if it is 3.2 or 2.2. But I assume it is 3.2. So you can complete this exercise. Tomorrow, I will ask if you have some doubts from this exercise. And then we will go with more questions over 1-1 many-one onto it. Got it? That would be all from my side for today. Thank you so much.